Well, welcome to our March 15th meeting. Let's talk about our agenda first, and then we'll just get rolling. So let's see. First off, there's a new quick bite, and it is posted today, and it compares the two breakout boards that we have, 64019, we call them by part numbers, and 640029. So the P2 Edge breakout board and then the P2 Edge mini breakout board. So there's a video here. You can go check that out. Those are the two boards. This one on the right is the newer one. That was Stephen Morocco's idea. And I posted a link to this quick bite in the chat. So you can go watch the video and compare the specs when you want. And if you want to get one of these right now, we have a bundle with the P2 Edge where you can get the Edge and then the breakout board for free, basically. So I'll throw this link in there.
I took you up on that, Ken.
Oh, you did? Thank you. I know you are really smart. You always find the sales and you go boom. I know your habits now. I look for those orders when I hit that big button.
Ken, at the just a quick observation on the page you just showed, it looked like there was a difference in supported compatible P2 Edge modules. Is that intentional?
It is that way. And I think it has to do with the RAM and pin IO allocations on the P2 Edge 32 megabyte.
Interesting.
Yeah. Do you know, Chip? Can you explain that?
No, I'm looking at that too. I don't know. I mean, the 32 megabytes missing about, what, 16 pins? From
Yes.
but I don't know.
So those pins then are therefore not fully accessible when we say all IOs, or maybe it's a conflict, right?
Right.
So
Yeah. Yeah. It could be that.
So follow the product link and the documentation will spell out that limitation for us.
I'll go research. It makes total sense.
Okay. Also, since you're speaking, Stephen, on this page, if you were going to get involved in our motor control stuff, we just made a few revisions to this drawing in the last couple days. So I think you're all aware because we talked about the brushless motor control reference design that we're putting out. And here's a platform you can get. It kind of looks like this. All right, it's just a piece of wood. It's not like a super robot chassis. It serves a purpose, okay? If you want to have a really, really cool robot chassis, there are lots of robots you could buy, but this one is nice because it fits our brushless motors and then the two casters.
And we will also be adding some power supply components, right?
Yeah, we'll have the parts in stock to basically assemble one of these, and there's a really nice 3-switch that we're going to add to it. And this is a really crazy fast, highly controllable robot. So again, it's for customers that want to, it'll just destroy your ankles, right? And your feet,
Yeah,
if you're careful.
Speaking of fast, it bolted across my garage one day unintentionally and kind of took out a plastic trash can.
That's better than the dog.
Some serious dents. It's pretty good.
Maybe we should put like a piece of hose around the edge of that thing, you know, cut open and pulled over.
Yeah, it's an ankle biter if you're not careful.
In my view, anything is safer than the Elevate quadcopter. So this thing doesn't fly and have spinning blades on it. You can jump over it.
Fewer dimensions of hurt.
Yeah.
It's trickier than a kid with a grocery cart behind you.
Yeah. Or a mom with a stroller.
You can be your own worst child with this one.
So let's see. Maybe let's talk about the topics today. There are 3 of them. We can put them in any order depending who wants to talk. Eric Smith is going to talk about FlexProp 600 release, which includes a flash file system, the little FS, and improved bytecode support for the P2. And then we have Terry Tripp will show off his spinner Edge. It's a WizNet 6100 Ethernet board that fits the P2 development boards. Nice. And that'll probably take him 10 minutes. And then he'll also give us a sneak peek at his full-size breakout board, which he really likes. And I think I saw him online doing his first surface mount reflow recently. And then we got Chip, who is going to discuss the progress on the RAM file system. So anyone have a preference for the order of these things? So maybe we'll do Eric, if you're here, right?
Yeah, I'm here.
Okay, so Eric is here. Why don't we do FlexProp? And then if Terry shows up, if he's already here, let me check.
Terry Trapp is here.
Okay, good. So maybe we'll do Terry, then Chip, you'll talk, okay?
All right.
All right, and so I'm on my backup internet today. I'm running on Elon Musk Starlink, and you'll see that I freeze in a sleepy looking position. And so Chip, I made you host so we can keep functioning when my system goes south, okay?
Right.
Because it's going to happen.
Yeah.
All right, well, what do you say, Eric?
Oh, okay, sure. Can I share my screen?
Yeah,
Oh,
one more thing. We had some P2 general P2 questions today from Grover.
Right.
Grover, do you
Yeah.
want to just see what those questions are, and we could maybe answer them now or delay them, then we'll let Eric.
Well, a couple of questions. This is going back in history before the P2 came to reality. I thought I remembered seeing some discussion online about the P2's design. And there was some discussion about having 16 cogs instead of 8. But of course, it ended up 8, which is not bad. But I wondered if that was, did I misread that, or was that just a feature that had to be dropped out at the time, or?
Yeah, so when we got down to synthesizing the final chip, it was gonna, if we were gonna have 16 cogs, we would only be able to have 128K of hub RAM. And so the forum members pretty much all agreed that it would be better to have 512K of RAM and only 8 cogs. So that's why we did that. Now, if we ever go to a smaller technology, we can have everything.
Oh, cool, cool. Yeah, 16 cogs would be good for certain kinds of apps.
Oh yeah, yeah. It stretches out the hub memory latency a little bit, you know. But yeah, it's more computation for sure.
Okay. Yeah, maybe that'd be a P3, huh?
Yes.
Okay. One other comment I wanted to make. One of the things I love about the P2, when I first saw it, I got a little excited, and that is the smart I/O pins. That feature seems to me to be pretty powerful because of all the capabilities that can give you. And isn't that designed so that you can have programmable pins, you know, with their own capabilities?
Yeah, that was the intent, you know, and we started out the whole thing trying to make something like what wound up in the, is it the Pico, or the PIOs, the programmable IO interfaces? But I found that trying to make like a generally programmable IO pin, it would take too many clocks to do a lot of things that need to be done in one clock oftentimes. Because if you think of all the things that a pin might do, you know, there's a handful of them that are pretty obvious. And a lot of those things need single cycle turnaround. There's not enough time to run, even if you're doing one instruction per clock, it's then too slow to do a lot of operations. So what I did is just wrote the hardware to perform what seemed like the most useful functions without any kind of like general programming approach.
Right.
So they're configurable, but not really programmable. So each pin has, you know, 31 personalities, 32 if you include just the native IO pin. So there's all kinds of PWM and ADC and scope and all sorts of stuff. DAC operations.
Right. One of the things I'd like to do is focus on building a digital oscilloscope. And I know digital oscilloscopes are, you know, prevalent today, but I would like to actually build one using the P2 and see what all kind of capabilities I could come up with.
Yeah, there are scope functions in the IO pins where they will have like a running chain of flops that you put the single bit ADC samples through, and they're moving through at the clock rate. And then there's a filter that can be applied to that to give you an actual like conversion value. And the trouble is though that the ADC's bandwidth is only about 4 megahertz. So if we ever get a chance to make another propeller chip, I would do some kind of like, instead of 1 bit, of feedback per clock, I would get like 15 or so that we can actually have a 4-bit conversion every clock, and then set it up so that it can handle a lot higher bandwidth signals. And then we could digitize, video if we wanted, and all kinds of stuff.
All kinds of high frequency stuff.
Yeah. But for now, I mean, it'll do, things below a megahertz really well. But when you get up to a couple megahertz, it starts to decay, and then you get a lot of phase shift.
Right. Is there anybody that's done something like that already that has some good programming examples?
Probably some stuff was put on the forum a long time ago, but it was nothing complete like a scope with controls. It would have just been some simple example where we're creating some waveforms and then we're digitizing them and then showing them on maybe like an HDMI monitor.
Right.
But now we have a lot of this debug stuff so that you could have virtual scopes on your PC screen that you could just feed data to.
Right.
And if you want to do really, now, you're limited by the baud rate, which is only 2 megabaud for the serial data going from the P2 to the PC. However, if you want to show some like fast triggering scope action, what you can do is you can capture it really quickly in the P2, then send it off in batches to the display scope. So you can get whatever, we have an example for the logic analyzer that's like 3 nanosecond cycle period or sample time. But that's like captured quickly and then sent off slowly. So you run a background operation to do these quick snapshots of little bits of time, and then you send those to the triggering scope on the PC.
Sure. Okay. All right. Well, those were my big questions at this time. So,
well, if you have more, you'll have an opportunity to ask them as we go through this.
yeah. Okay.
Okay, thanks. There are some debug examples. Maybe someone wants to find them and post them that have some scope-like functions in them from early on. They're in quick bytes.
Good.
Okay, so yeah, I'll find them if they don't show up in the chat. So just keep watch over there. All right, next up, so as we go over to Eric, I just want to alert you to his Patreon page. So if you like FlexProp, you can also pay him for it. So here's his page, and I just put a link in the chat. And as you can see, I have to update my payment information because 2 people I support are not presently getting paid, but they never complain. So I'll go do that while Eric gets going.
Thank you, Ken.
Yeah.
So I'm just gonna try to share my screen here. All right, can you see it?
Looking good.
Okay, so yeah, I've released a new version of FlexProp. I just uploaded it to GitHub. It's actually 6.0.1. Right after I sent the 6.0.0 up to my Patreon page, I found that there was a missing file. So I've fixed that. So the 2 main features of it that warrant the 6th release are a flash memory file system and support for compiling to bytecode. Actually, Ada had done a P1 bytecode compiler a while ago, and that's working really well. And it's really nice to have for the P1 because the memory is so limited. And since then, I've added a P2 bytecode compiler that's mostly working. I think there's still a few bugs, but it's certainly usable for a lot of things. And I'll discuss that later, but I wanted to start with the flash file system. So you can use this from any language. It's easiest from C and BASIC probably, because it's a C library function. And I've got there's a demo called flash.basic in the samples that come with FlexProp. So I'll show how to load it. You go to File, open file, and you find the samples directory. And there's various samples in there, and the one we're interested in is flash.basic. An example of using the built-in flash memory to save data. So you can set up the configuration that you want to, how you want to use the flash. The page size pretty much has to be 256 bytes, but I think all the flash chips use that. The erase block size can be either 6K or 64K or 4K, depending on your chip. I know the eval board uses a 64K erases. I'm not sure about the Edge. I haven't tried it there. And then you specify where you want to start your file system and how big you want the file system to be. So in this demo, I chose to start at 2 megabytes, which leaves lots of room for the initial program to load. And, you know, if you have overlays or some other stuff that goes down at the beginning. And 6 megabytes is really conservative. Most chips are 16 megabytes, so we could probably make this 14. So this, and then there's some reserved words. At some point, I'd like to be able to specify what pins you're using. For now, it only uses the default pins that are used for boot. So actually mounting the file system is really simple. You just say mount and then a directory name that you want it to be mounted on. VFS open, little fs flash, and then a parameter that says whether to format it or not. So if the flash is not already formatted and auto format yes is set, then it will format it for you. If auto format no is passed, then it won't do anything, it'll just fail. And then you can pass in the configuration, which is that array. If you pass a 0 here, it'll use the default configuration, which actually happens to match this one. But for the demo, I wanted to put everything out explicitly. And then to actually read or write, you just use the standard basic or C read and write commands like open flash message.txt is what I called the file for input. And you read it in with input $. You can print it on the screen and then you close the file. And similarly to write the data, you open for output. And then you print to it, like print number 3, because that's what we opened it as. And then loop. So, whoops, sorry, I want to compile and run on P2. Okay, so I can either see if there's an existing previous message or save a new message. So we'll start with a new message. Type in what I want to type. Now, if I ask to see the message, it shows up here. And I can reboot my board. I'll compile and run again. And it's still there in the flash. Now, all this is completely integrated with all the other file system commands. So for example, there's a C shell demo. That just has a really simple command line shell. And that starts by mounting a host file system. But you can also tell it to mount the flash. And look at what's in the flash. And there's the message.txt that we just entered, showing up as a regular file on the file system. And you can access that flash data from any program that uses the file system. And And with the shell, you can do things like making a subdirectory. In the flash. This one's empty, of course. And all the usual file operations, change dir, copy, delete. So it's a handy utility for copying things around. You can copy things from the host. Starts out in the shell directory. So we could copy like the readme.md from the host PC. To the flash. And so now it'll show up on the flash. And the shell, we can also access an SD card. Formatted with a flash, with the FAT32 file system. You can't have the flash and the SD mounted at the same time because they use the same pins. So unfortunately, to copy things from the flash to the SD or vice versa, you have to go through the PC. So I could copy, that shell.c file on my SD card, I could copy to the host and then copy that to the flash by unmounting. And if you try to mount, it should just give an error. Yeah, it needs a better error message. I need to fix my shell program, but.
Eric,
Yes.
you're suggesting that the mount SD command then actually unmounted the flash? Oh, you did it by hand.
I did it by hand right here.
Okay.
Yep.
Okay. If you did try and it was mounted on flash, would there be an error message?
Yeah, just like this one when I tried to mount the flash.
Gotcha.
So if I unmount, mount flash. See, it's still there. Yep, it is. And so there's the README file that I copied earlier.
Nice.
And now if I try to mount the SD, it'll fail.
Good. Okay. Yeah.
Boy, that's awesome, Eric. That's pretty thorough.
Yeah, it's kind of handy having this little shell, and it's actually accessible from the FlexProp special menu. You can run the command shell, or you can go to the samples and find the source code and compile and run it from there.
Wow. I've started working on our file system again. You've done a lot of like infrastructural work here too to make it kind of contextualized. So you have a command processor and everything.
Yeah, it's well, I didn't have to write the file system because it's one that ARM wrote for their chips, but they released it under a BSD license. So I didn't have to write the file system. I just had to hook it up to the FlexProp file IO.
That's cool. How big was it? Very large?
It is pretty big. Let's see if I can find. Where's the samples? So that little flash binary is 80K with everything linked in.
80K. So okay. So that sits in hub RAM.
That sits in. Now, actually, I can compile it using bytecode, which will make it a lot smaller, I think. So to configure for bytecode, you have to go to the commands and configure commands and click on P2 bytecode defaults. And now if I go to the Flash Basic. Okay. I think it actually outputs the program size is 28K. So it's a lot smaller.
Wow. So it got like 40% the size or so.
Yeah. Well, the normal output, you can actually look at the listing file. So this is the bytecode output. So it's got all the bytes. here, whereas when I compiled it before, it was P2 ASM code, right? So it'll be a lot bigger.
Yeah.
Now the bytecode I'm using is actually kind of funny. Actually, you can see what's on the listing file here. It generates the bytecodes itself. It goes through, it compiles
Yeah,
the
on kind
program
of an as needed basis, right?
yeah, it builds using like a basic set of primitives, you know, push, pop, and so on. And then it goes through and looks to see if there's any things that it can combine. So it starts off, let's just try to scroll down here and find the table for the bytecodes. These are all the implementations. Is there a page?
So it's using the X byte thing, right?
It is using XByte, which is really nice, Tripp. You did a good job on that. Now it doesn't really use the exec feature very much, just for a few of the opcodes that are built in.
Right. Yeah.
Because, okay, yeah, here's the sort of basic ones that it always includes if they're needed. It only includes something if they're needed. So like if you never store a byte, it wouldn't bother including the store byte opcode.
So that's dead bytecode removal.
Yeah. And then after it's sent out all of those, I think inline ASM is usually the last one. Oh, no, there's a few others.
Oh man,
It will then start combining them. So like it noticed that very commonly after an add dbase, there's a load long. So it combined the two of them, and add dbase store long. These ones almost always get omitted because as you can imagine, if you're doing stuff with dbase, and then it noticed that push 0 followed by add dbase followed by load long was really common. And it kind of works its way down the list, combining as long as it saves memory to combine.
oh man, that's really thorough.
So it's kind of a neat, and there's the generates the table, and somewhere here, oh yeah, and it always emits pushes for the first 100 or so numbers, just because they're really easy to create and don't take any code space.
Did I understand that right? It reads and writes dbase files?
No.
No. Sorry, dbase is the name of a register in the interpreter.
Oh, okay.
Yeah, it's like the base of the data stack. So
Yeah.
the data, it's like the runtime data stack base,
Gotcha. Okay,
Yeah.
which moves
So-
around as you go into nest into calls and things.
sure.
Yeah, exactly. So it goes through and looks at how many times each of these are used. And when it first generates the table, it's sorted in order of use, but then as it combines opcodes, the number of uses does drop. So like the load long was probably used 500 and 40 times, but now it's been combined, so there's only 171 standalone load longs left.
Wow.
And so on for all these. So yeah, it's substantially smaller. Like I say, this demo program is 28K now for writing the Flash. The other nice thing about kind of going back to the file system stuff, the other nice thing about this is that for testing, you can use any of the file systems. So we could use the host file system instead. Compile and run it. So there shouldn't be any message on the host. Nope, there wasn't. So let's save a new one. So this should save it on the host PC. Oh, I hit the wrong number. I'll type it again. See the previous message, hello to host PC. And if I go up to my host directory, there should be a message.txt file. There it is, with the message that I just saved. So I only needed to change one line in this program to write data to the Flash, to the host PC instead of to the Flash. I just had to mount a different And same thing, you know, if I wanted to write to an SD card, I would mount this directory as a VFS open SD card instead of host.
Could
So
you, if
it's-
someone wanted to copy files between the SD and the flash, could you kind of piecewise do it where you like buffer some, you know, data in RAM and then kind of mount and unmount and swap back and forth? And
you could, you'd have to unmount, you know, mount and
Yeah.
unmount. So you'd mount, open the file, read the file in, unmount, and then mount the other side, right? And then unmount.
could
It's
you
awkward.
even, yeah, it would be awkward. How much RAM? So if the code is like 28K in bytecode, how much RAM does it take to support that? I mean, RAM like variable space RAM.
Yeah, well, the 80K that we saw in the
The P2 and
the assembly actually includes everything, including the
Oh,
variables. The
okay.
bytecode doesn't. The bytecode relies on the memory being zeroed, and or actually it zeroes the memory. So it
Right, but
produces.
that's in addition to the 28K, right?
Yeah, yeah. I don't think I have a way to print variable size right now.
Hey, can you cause it to print out like the help menu again? Because I notice it's kind of like all Linux type stuff. And I wonder if, you know, today younger programmers probably never messed with DOS, but they're probably playing with more Linux based things. So they're probably more inclined to know Linux commands. Okay, I'm going to take a screen check. I just want to save this.
Yeah, this is the shell program. I did use, I don't think I included all the aliases, but you can actually do ls instead of dir.
Oh, okay.
So a lot of it's the same.
I have a quick question, and maybe I missed it. Do you have the ability to copy things that are on the little file system out to the host PC and vice
Yes,
versa?
yeah,
Okay.
absolutely.
Okay.
So let me
So
mount the
it's
flash.
so if you had one in that was already in a disconnected state, it had data on it, you needed to pull that data off the little file system, you could connect it up and then just copy it over, right?
Right. So if I wanted to copy that boot
Okay.
count file, I would just say copy flash boot count to /host/boot count.
Ah, okay.
And if I look up here on my PC, I may have to refresh the.
And I apologize if you already covered that.
I'm not sure if I did. It's kind of implicit, but there should be a boot count file. Oh, I don't see the boot count file. Did something go wrong? Let me get a shell.
It should be in the shell subdirectory, I think.
Oh, yes, it's in the shell subdirectory. Of course, you're right, because we ran from the shell subdirectory. There it is. Thank you, Ada. Yeah, the host file system is connected to wherever you're running from. So like where your program is. So you can't read arbitrary locations on the host PC. You can only read from where you ran it and lower. I mean, it's not a very good security feature, but it's kind of it's a sort of security feature.
Right.
Your P2
Yeah.
can't totally delete your whole hard drive or anything.
What if it were to put like a batch file into that directory that did that and then executed it?
Well, I can't execute anything on the host.
Okay.
You'd have to click on the batch file on your host. And incidentally, as you can probably see from my screen, I'm running Linux here. FlexProp works on Linux, Windows, and the Mac. And has pretty similar interface on all of them. To get a really nice interface, you use Visual Code, or Visual Studio Code, which Stephen has ported to all of those targets. And I think there's a quick bite for how to do that.
Would that use, which language would that use? C or C# or what?
For programming the P2 or for,
No, if you were going to use Visual Studio.
All the
you
language.
can use Visual Studio Code. It's not the same as Visual Studio. It's confusing.
Oh, okay.
Visual Studio Code is like an editor, and you can hook it up to compile Spin and Basic and C for the P2.
Okay, I got you. Sorry, I guess that was a dumb question. Sorry about that.
No, it's okay. There are no dumb questions.
No, I'm used to Visual Studio languages, so anyway.
Yeah.
Eric, a quick question for you. Is there enough of a signature on your Flash image that that once Chip releases his, the two of you can defend against overwriting each other's images?
Well, I think the little FS does have some structures built in. And as I say, there's a configuration here that you can specify where your image is supposed to be.
Yeah, I have that same thing for mine. So you can say what's the starting and ending block in
Right.
4K blocks.
So the question is, should we be thinking about this then?
Yeah, you would definitely want to set auto format to no when you go to mount. And if it doesn't find a little FS and auto format is no, it'll just fail the mount.
But if we put in some detection, then the user will have useful messages about why it's not there.
Right.
Versus forgetting that they had initialized it a different way and then wiping something out accidentally.
Yes.
Well, and you can strain all of your activity to those memory bounds, right? So you're not going to blow up anything outside of that range.
That's correct. Yeah.
Yeah, and that's how mine would work too. So you just have to have maybe one mounted or the other.
Right.
Is there any type of magic number that either of you guys use to indicate if your file system is, hey, this is my file system? Like at the beginning of it?
I don't know. I mean, he had to come up with some format, or that ARM did, and then I came up with some format, and mine is really centered around like surviving power downs. And so there's a lot of like break before make kind of stuff with single bits. And I don't know how the one Eric's using works.
Typically,
oh, go ahead, Stephen.
Okay, what I was thinking is certainly for files, there's typically encoding at the left edge of the more complex file formats, the very first couple of bytes. In file systems, there's typically, I think it's typical that there's something in the very first, in the boot sector as a marker, as a signature. The first sector is reserved for boot. And so if we made that as a case, little fs would probably have something in the very first sector identifying it as a little fs structure. And then Chip, you should think of putting some sort of signature, a 2 or 4 byte signature out there that would make yours unique somewhere. And then the two of you can just look for that little signature and know that if that signature is present at the location, you'd be able to find it. You'd be able to know what the file system was. I understand your ability to relocate the file system based on this table. That also suggests that you probably have or will have a couple of likely locations most often used for the file system, and that you could probably poke in those locations to recognize these signatures. Does that all make sense?
Yeah, I think so.
Eric, I have a question for you.
Yes, Mike.
Since we now have access to the host file system SD and Flash, is there any chance that you support the file system on the P2 Edge RAM, external RAM?
Like
a RAM disk?
Yeah, like a RAM disk.
It could be done.
I mean, that would be perfectly nice to use the either the hyper RAM or the RAM on the edge. You can load it from. We have no conflict there with matching with mounting SD card, so you could copy from SD to HyperRAM or RAM. And
Yes,
also
that would
use
be
that to copy. Also
use
use
that to copy. Yeah. Yeah, the little FS actually, the way ARM structured it, it's really easy to put it onto different back ends. Like I've used an SPI that Nicholas wrote, Man at Work on the forums, had a very simple SPI flash driver that I used, but they come, they provide examples of how to do it.
I kind of combine it with Roger's work.
Yeah, no, it certainly could be done. It wouldn't be hard.
That would be cool.
I haven't done it yet. I don't actually have the Edge with 32 megabytes, but
You should change that.
well, I think Ray's offered to send me one of his external RAM boards, so I'll certainly test with that.
Well, we
Yeah,
could,
that's
if
cool.
you want one of those, Eric, we can send you one. That's no problem.
Oh, if you have a spare.
Oh yeah, we can spare one. Let's see. I'll email Ken about this.
Thank you. As I say, it shouldn't be hard to set it up to use RAM instead of flash. I mean, it's just using a different driver underneath.
That would make things so easy then.
Yeah, it's a pretty fancy file system, but it has a lot of features like directories, long file names. I think the file name limit is 255 characters. So it's
So it does support a long file system also on SD cards?
an SD card, it's up to you. When you compile your program, you have to define a symbol to get long file
Okay,
names.
cool.
By default, it just uses the 8.3.
8.3, no? Yeah, cool. It's getting better and better.
Oh yeah, this thing's really complete, boy.
And yeah, obviously it's easy to use from BASIC and C. Now, I don't have a spin object at the moment, although you can use C from spin, so it wouldn't be hard, but it would only work in FlexProp, obviously, because it would be compiling the C code. Little FS is fairly complicated, so I'm not sure porting it to spin would be much fun.
Yeah.
Yeah, but if you include the CLib thing, then you basically could use the C read and write functions in spin, right?
Yes, exactly.
Yeah, cool.
But that's only for FlexProp. I'm actually looking into figuring out a way to turn the assembly, because by default this generates assembly code, right? I'll configure it back to assembly, E2 defaults. And that assembly code, in theory, could be made into a spin2 object. Chip does have hub exec, right? So,
Oh gosh.
all this kind of stuff like the basic get character call could be emitted as. So we'd need to put little spin wrappers around it. So that would be one way to get this working in Chip's compiler.
Probably, yeah, well, might
Yeah.
be maybe a bit of an ill fit.
Well, yeah, I mean, it wouldn't be the ideal solution, but
it's a big assembler blob.
it would be an assembler blob that would be the library. Yeah. So, I mean, it would be an object. So it would provide the read and write and so on.
Cool. I like that.
It would just look like this, the assembly code. this listing file is kind of handy for finding bugs, especially if it's used in conjunction with Tripp's debug statements. You can take the assembly, insert debug, and then see where things are happening. What would be really nice, and I'm sorry to bug you about this, Tripp, but just having a standalone assembly debugger would be so handy for anyone doing anything, assembly development on the.
I wonder, well, let me think about that. I'm just trying to think of what tendrils would be needed, because the whole thing is kind of a mixture of things, right? So I'd have to think about where it could be divided. Maybe it could be really simple.
Yeah, I think what we would need would be some way to download the assembly language program like this, along with a little stub that lived in the debug area.
Right.
And then a way to put in breakpoints. So the PC would download this code, download the stub, but not execute it yet, download the stub, and then insert some breakpoints, at the beginning of main or wherever.
Yes. Well, we could do that now, because in order to make debug work, it has to like run some code before the application runs in order to set everything up, so that the breakpoints are going to work. If you did what you're saying and you put like a spin wrapper on this, you could debug it then, right?
Well, sure. What I'm thinking is more along the lines of just debugging an arbitrary binary. It's compiled not with peanut.
There's the whole issue of like getting symbolic names into the thing.
That's a lot harder, but even just being able to single step and see where you are in memory, combined with a listing file like this, like if I knew I was getting to this point in the program, to call this function, and then I never got past it, then I would know there's a bug in this function,
right.
And even if I didn't have the symbols, if I could see the address and have a listing file, I could look it up myself.
I think as is, you could probably just open the assembly output in Peanut and then have that, and then it will start up the debugger, I think. I haven't tried it.
Oh, sure, you probably could. No, there's if-defs in it, but you can recompile it with FlexProp. Again, I do that all the time. Like I take the assembly language output by FlexProp, insert some debug statements, compile it again with FlexProp. And because you added debug support to FlexProp, right?
I've never used it like that though.
Yeah, you can set the break debug method, and then like open. You have to rename it to .spin2, but that works fine. Yeah.
Oh, I'm always just looking at the listings and like applying raw brain power to find the bugs. I don't
well, that's
know.
probably the best way, but no, what I usually do is I will compile it, I just do compile for P2, and then I rename the PASM file, like the shell.p2asm. I don't think this interface will let me rename, but I rename that to shell.spin2, and then open it up and insert the debug statements I want. So it's doable.
Weird Linux file chooser experience.
Yeah, I can open it, but I think it would be dangerous to compile this. Let me see. We can try it. I'll put in a debug statement here.
Send it.
It was
what
like
could go wrong? We're in
this
a demo.
year when they finally added like thumbnails to the GTK file chooser. Unbelievable.
Oh yeah, it worked. Okay, so that works. You can actually just stick in a debug statement inside the. So you can so
it is working already then.
Well, again, it's not as convenient as being able to single step or
Oh, right. Yeah, that's,
dump
yeah.
memory.
Well, that code is all on that P2 Peanut public thing. It's not huge, but
Again, though, every one of us, like I would have to re-implement it. Ross would have to re-implement it. You know, anyone
Right.
doing a P2 tool. So it'd be kind of handy if there was a loader program that wasn't a compiler that just loaded a binary and let you execute that binary under a debugger. So you could put breakpoints in, single step, look at the memory.
We have a number of
Yes.
questions in the chat.
Oh, I haven't been looking, sorry.
Maybe start up at Michael's. If the SD card was connected to other pins that are not sharing the flash pins, would you be able to mount it alongside the flash?
Yes, it actually uses a bit mask of pins.
And then copy one to the other?
Yes, so if you
Wow.
had your SD on a different set of pins, you could mount them both.
Okay, and then here's a good question that Shannon asked. I had the same one. How is Eric's file system related to Chip's flash file system with where leveling?
They're
And then
two
he said
different
DBase.
animals.
Yeah, I
Oh,
think
okay.
that was really answered well with the whole discussion, so I withdraw that question.
Okay, good. Then
And
how
a
about Don
small F-
O'Brien's?
Let's see. There's a what was I going to say? I forgot. Oh, okay. Where leveling is part of the small FS, right? Is that what this thing's called, Eric?
Little FS.
Little FS,
yeah.
yeah, it
Little
definitely
FS.
does. It's got a pretty sophisticated wear leveling, I think. ARM put a lot of effort into it.
Okay.
So it does do wear leveling.
All right.
And
Brian's
largest
question.
What's the largest onboard flash the P2 EC is ever likely to see? I guess I'll defer that to Chip.
Well, I think right now we're using these parts that use a 4-byte command structure, and 3 of those bytes is address. So that's a 16 megabyte address range. And I don't really know. I know that you can get bigger chips than that, but they have a slightly different protocol for accessing that extended memory. I'd have to look into it. I'm sure we could do it. It's probably just a matter of some software, right?
Okay, so maybe we should go to Terry's workbench, Chip, and then come back to
Yep.
your file system.
Okay.
Hey guys.
Hey.
All right. So I've got a little thing to share here that I've been working on. So let me kind of show you guys. Previously, you guys know that I've been working with the WizNet, and so this is the thing that I originally wired up to get going to work with the WizNet, and it's a mess. It takes up a lot of room and everything. And so I've never designed a surface mount SMT board, and I went ahead and made this little guy right here.
Oh, awesome.
For the WizNet. And so this is sort of my first experience into this. I do this for fun. This is not how I make money or anything. So this is a complete hobby for me. So I went ahead, and it's also the first board that I made with KiCad. So I had been using, I think PC Board Express or Express PC Board, one of those guys. And KiCad is nice. It is really nice. So I highly recommend that.
You would recommend what CAD?
It's I don't know if I'm pronouncing it correctly. It's KiCad, KiCad.
Oh, KiCad. Okay. Yes.
Yeah. And it's open source. I believe it didn't cost anything. And how big things actually are, and even looking at what it rendered, I was still a little bit off. This board's much bigger than I really wanted it to be. But it worked out really well. And I had a lot of help from the guys on the forums. Let me go ahead and show you what the result of it is. Hopefully I can change cameras here. And this may be upside down. I'm not sure. Yeah, there we go.
Sorry to interrupt. Ken, are you still under the snow?
Yes, sir.
I heard it was 8 feet above your head.
That's right.
Yeah, lucky you.
Those are some amazing pictures you posted, Ken.
Yeah, they were telling me that you had to use a ladder to get down to your propane tank.
Yep.
So yeah, here's the first one that I made with the components on it. I used a set of tweezers to set all the components. Used a stencil to put the solder paste out, and I went ahead and soldered it with a rework iron, air iron, and I had one cold solder joint, and it took me like one weekend to figure it out, figure out why it wouldn't work. I was sitting there looking at everything, reviewing everything. It's like, did I mess up on the layout or anything? And finally, after reflowing that little resistor right there, it came up and gave me link. I was able to talk to the chip, but I couldn't get it on the Ethernet. And so now we have our link lights there. We have it up and running. And by the way, I love this new P2 Edge board that does the full breakout of all 32 pins. That is so nice. I love it. So I got this thing set up, and I can do a screen share here. So I have basically the same little web server and files that I use for my light controller project loaded on the SD card. And so whenever I share, you'll see the normal page. I haven't had an opportunity to change the files I have in there, but something I did do is I have this old Radio Shack camera that I bought whenever Radio Shack went out of business, and it's a little camera board that they sell, and it has just a serial output on it. It does have an SPI output, and it requires you to communicate on the SPI as a slave interface. And I couldn't find a good example of that out there. And I went ahead and just send data over the very slow serial interface. It took me a couple of days to rig up a thing, but I now have it where we have a webcam set up with this thing. So let me swap over to sharing my screen. Change the camera around, share screen. I want to share that screen. And can you guys see my screen?
No.
No.
We can see you, but that's it.
There we go.
Okay. Oh wow. All right. There we go. Let me move that out of the way. So this right here is the web server. I may have touched something and it's not working now. Nope, it's working. It takes a second the first time around. As you can see, the requests are coming in, and I've got the debug statements coming out, and that's all stuff that you guys have seen before. This is the thing that I worked on the past couple of nights. It's kind of fun. It takes 5 seconds for the data to come from that webcam over to the P2, and then it spits it out almost immediately. And I probably didn't get a good picture here, but that's the webcam. Let me give a nice wave there and see if that shows up. There we go. And so that's rigged up. So that's just something I wanted to show off real quick. Is
is that like JPEG compressed by the camera module?
Yes, it's JPEG compressed by the camera module. And actually looking for the header, I think it's like FFDB or something like that. FF. Whenever I saw that, I'm like, oh, that's where the data is. It's coming from the camera.
So Terry, so you've got this WizNet, which is now conveying this data, right, from this camera. But is it going? It's going through the P2.
It's going through. It's going through the P2. So this serial receive that you see right here are the commands that are coming back from the camera. So here's where the request came in for webcam.pix. And whenever it sees that file name, it's like, oh, you want to get something from the web, from the webcam. And so here is the response whenever I ask for the version of the web camera. Here's the response I get from telling it, hey, advance to the next frame. And then I tell it to stop the frame. And then I tell it, do I do that? Yes. And then I say, okay, tell me how large the frame buffer is. And so it comes back with this response. These last 4 bytes right here are how large the image is that's in the frame buffer. And then I tell it, okay, go ahead and get the data. And so it reads the frame buffer and it returns the it returns a code saying, okay, here comes the frame buffer data, and then it sends the image, and then it says, okay, I'm done sending you information for the frame buffer, and then it ends.
Now, where does the data go for the image? Because the P2 is not really in that path, is it?
Yes, it is. Let's see here. See if I can.
And then is it being rendered on that screen? I mean, that was the PC that took that JPEG image and unwound it and made it
an image. Yes.
Right.
So what happens here? I can go ahead and just show you the get image code here. No, please, guys, be kind. This is just a complete hack that I put together in like the past couple of evenings for fun. 2 days ago, I couldn't talk to this thing. So, here's where it's going through. It's getting the version. It gets the start of the current frame, tells it to stop the current frame, which is, it has a frame buffer that you can tell it to start and stop. And wherever it stops is what gets left in the frame buffer. And tell it, okay, go ahead and get the length of the frame buffer. It pulls that down. And what it does is whenever it's pulling the data, where do I have that at? That is right here. Okay, I fill a byte array called image. And so it just reads a serial byte and it puts it into the byte in HubRAM, and it does it I times. And I is the size of the image. As you can see right here is where I'm populating I from those 4 bytes. I just tell it, okay, get a byte, shift left, get a byte, shift left, get a byte, shift left, and then add the last byte to it.
So you buffer it up in the P2, but then you're not displaying it on the P2, right? You're sending it off to the PC somehow.
Yeah, correct. So and these little lines right here are literally what's sending it out. Or this is what assembles it. It says, okay, if it's a webcam.pix, then you set up the header, which is the response header that has to go out to the web browser.
So you're going to send it back out the Ethernet that it came in on?
No, it's coming in on serial.
Oh.
It's coming in on, and it's literally just a serial connection. It's running at 115.2, so it's not fast. That's why it takes like 5 seconds. Oh my goodness.
Okay, so this webcam is like kind of probably sort of low res.
Yeah, I think it's 640 by 480. Okay. After doing a little research, I found that they actually have like some that are a couple of megabit in size, but the only interface to the webcam is just serial and SPI, and you can use the serial to send commands to the camera. You can use SPI to receive the data back, or you can tell it just use the serial interface to receive the data back for the asynchronous serial. And I could not figure out in one day how to write a SPI receiver that acts as a slave. I'm sure if I sat down, I could probably knock it out in a few days. So I'm like, we'll just go ahead and go with what we got. actually had to sniff the wire to figure out the correct commands to make it come out the serial, because there is a utility for that camera that's like a Windows utility that will pull it'll pull the image across the serial. So I went ahead and hooked up my logic analyzer and said, okay, what's it doing to pull that image? And then I just imitated that, because the examples that are on the out on the web don't show how to do it that way, but the tool could do it.
I see. Okay, so then you're sending it off to the PC where it gets displayed. Now, would you
Yeah.
have any interest in having the P2 display it for any reason?
I think that would be cool if we had a JPEG decoder to be able to do that. I think there is a way with this chip where you could, it has a way of sending back a bitmap in 565 format. And
Oh, okay, because you could send that probably to a debug window in just bitmap mode. But I'm wondering if we
Okay.
should make a type of debug window that just takes a JPEG and just displays it.
Yeah, that could absolutely be done. I would imagine you would just have to write the plugin to be able to consume that JPEG and display it. I bet there's probably already a library
Oh yeah, there
of it,
probably is. Yeah.
to be able to do that. Yeah, so I think that would be cool. That was actually my first intuition, was to see if I could do that. And I'm like, you know what? I'm not good enough at that debug stuff yet to be able to do it. I'm like, I know how my code works for this web server, so we'll just go that route with it.
Well, yeah, if you had a 565, well, there is a 565 RGB format. You could use that. And you would just set it up and just send those same pixels and it would display. So it wouldn't be the P2 displaying, but it would be on your
It
PC
would be, yeah.
for the debug.
Yeah, but yeah, so the way it sends that out, it does your header, and then this is what actually calls the get image. Get image returns the size of the image, and we know that it's being put into at image. So we go ahead and on our web buffer, we go ahead. All right, so whatever we start the web buffer at the end of our header that we sent out here. So it's buffer plus the response for JPEG, and then we just go ahead and add on the image, the length of the image, and we update our size for the entire length of both the header and the image. And down here is the code that just sends it out to the Ethernet, is that right there.
Okay.
So it goes through there and iterates, and if it's more than a 1,000 bytes, it goes ahead and assembles it into the next packet.
And did you want to do this because you use for all your Christmas light stuff, you're using Ethernet already, right?
Mm-hmm. Correct. Yep.
So you wanted to be able to just push camera data through the same system. Was that the idea?
Well, the reason for the camera was just, hey, I wanted to show that this board works, and here's something you can do with it. It was just a demo thing, and I had this thing laying around for 10 years. I've had this camera. This is a 15-year-old device, and it's like, I've never done anything with it. Let's see if we can make it work. You know?
I see.
It was just something laying around. Yeah, so yeah, I wanted to do something a little bit different from the light controller stuff, just kind of showing how this little WizNet board works. I know there have been a couple of people interested in them, and I'm probably going to build a handful of them. So just if you guys want one, you can reach me on the forums.
Well, you just sold a dozen of them.
I wish.
No, I saw the hands go up. Brian has
okay.
a question in the chat too, Terry.
Yeah.
I guess he's wondering, is your code going to be shared? Do you want help? What's your collaboration?
Oh,
desire?
well, so for the Ethernet side, yes, I would love for someone to help out with that. I have that code actually in a repository out on Azure DevOps, and I can provide a link for that. It's all baked into my light controller project, and I've thought about trying to separate those at this point because the way that it's put together, they're really tightly coupled for the most part. But it would be kind of nice to go ahead and decouple that somewhat to where you just have like a low level Ethernet driver, and then if you want to do the higher level things, you want to do a web server, you want to do like DHCP, DNS, and all those things. Those can just be different modules that you can include in to your project, and just kind of get the all of those tools together in one spot, because I know there's limited there's a limited audience for the light controller stuff that I did.
That seems like a positive reply. They would like a link.
Yeah. Let me pop that in there. So
Terry, while you're popping that, you fly airplanes? See the one behind you.
Oh, so my son's really gotten into flying models, and I have one, and he just turned 11, and man, he's really good. He can fly a lot better than me. And so I've got us all signed up, and they're kind of doing that stuff out at the local club.
Yeah, I'm a flight instructor. That's why I asked. I saw that back there.
Oh, okay. Yeah. It's the little model stuff is fun. Real airplanes, I think I would kill me if I had the opportunity to do that.
Well, any other questions for Terry? Anyone can put them in the chat or just ask him while he goes on this link hunt. Well, this is great, Terry, and I've been following it online too. When you post it, it's fun.
Oh, well, thanks, Ken. Yeah, it's I did a whole video of me trying to do this board, and it's actually the process of doing the pick and place and all that stuff. I kind of like it. There's kind of you get into the kind of the Zen mode of picking the pieces and placing them on the board, and after you apply that heat, everything just kind of goes into the place that it's supposed to. It's a lot more intimidating than it actually is to do that stuff. So I'm really kind of enjoying it a little bit. I'm thinking about trying to build a P1 edge card to plug in, so I can have a P1 and use my edge boards. Let's see here, and I've
yes, that would be really nice. There's a project which was done for the spinneret. I think Mike Gebhardt did main of all of it, and I kind of just plugged in some editor stuff, and that's basically a web server with a VS 5000, I think it's still. So it just has 4
it has the four sockets.
Second driver for the 5.5 chip. So maybe we can kind of build a driver for that 6000 what you are using. The rest is implemented in Spin. So it's
this driver
somewhere.
Yeah, this driver is completely in Spin. Now, it does have some inline PASM.
Yeah.
But it actually is cogless. It doesn't even require a cog for the Ethernet.
Cool.
It uses locks, and so whenever somebody needs to request the Ethernet, you have to go check out a lock, and or the driver goes and checks out a lock, and it doesn't matter which cog is trying to access it. They'll just sit there and continue, whenever they need to access it. If it can't get a lock, it'll keep trying until it can, and then it will perform whatever the request is, and then it returns the lock. And it's like in my little light controller project, I have 1, 2, three or four cogs that are interacting with the Ethernet, and the
Cool.
locks work really great. I mean, it's that whole interface is actually quite robust as far as allowing you to be able to do something like that and not consume a whole cog with trying to talk to a device.
Cool.
Yeah, that's how the debugging works. It's all peer-to-peer, and it's just who gets the baton. They take over the serial resource, the memory resource. So you can have like all eight cogs in assembly level debug simultaneously. And they just kind of
Nice.
take turns.
Yeah, I was concerned about prioritizing that and who would get more bite. If some of those processes should get more bites at the apple than others, because web server, I'm not really concerned about that. Receiving that light data, for the E131 UDP information, I want that. Everything else, it can drop anything else, but actually it has no problem with doing the round robin and just letting the hub do what the hub does, and it works.
It's kind of almost accidental. But maybe it's because it does do a round robin and it checks, okay, if you don't want it, if cog 0 doesn't want it, does cog 1 want it? And then it leaves off and goes to whoever's next. So it must just kind of come out in the wash that it's, kind of equal to everybody.
Yeah, I tried to prioritize it and it made it worse. And I was like, okay, if I remove the priority, then everybody's getting what they need, and it just worked.
Good. Hey, I have a question for Brian Holdsworth. You're here, right? So does PMUT work on a Raspberry Pi?
Remember, he usually has Linux audio issues
Oh,
with
yeah.
Zoom.
Maybe you
So,
could type something.
yeah.
Because someone asked me the other day, and I don't remember who or where, but if I can remember the answer and I come across the question again, I'll answer it.
I think it still uses the assembly compiler, so probably not from what I told last time. However, there's something called Box 86, which lets you run x86 software on ARM, and that might work with that.
Okay.
So
See, I was going to say Jacob Jones had a question about how each cog knows, does it use port numbers to determine what cog packets to come to, for packets to come to. So the way the WizNets work is you have 8 different quote sockets, and those can be UDP sockets or TCP sockets. And whenever you have a cog that's looking for a specific service of interest, that cog chooses which of those sockets it's going to go look for. And so even if you're receiving data, you have to configure a socket to receive data. And so you have to know which one of the sockets the cog needs to pick up data for. And because of that paradigm, it allows it to be cogless and works pretty good.
Okay, well, thanks, Terry. Should we move on to Chip's file system update? Okay,
Yeah.
I have a short question for Chip in between.
go ahead.
Last year we both talked about that you had some ADC feature which was external clocked. And you told me that I might be able to use that when I just don't activate ADC to have an external clocked input with a streamer.
Yeah, so you know what, is Michael Mulholland still on here? Yes, he is. He did a board for that, and the idea was it would eventually implement it onto a P2 edge. So we would have like lots of RAM, real-time clock, 16 megabyte flash. So we have the basis for a system. So Michael, what I know he built a board. I think he sent me one, but we found a nice small coin battery. But Michael could show you some pictures of the whole thing.
Yeah, my question is what smart pin mode allows external input, external clocked input? I would.
For like, you mean for like tallying up edges or measuring?
No, I would
time?
like simply to transfer data between two P2s on X pins, but clocked by one P2 when sending to the other.
Okay, so you're just wondering like what kind of smart pin modes could make that
Yes.
easy?
Yes.
I would just pick a serial baud rate and just use serial because it signals when done, you know, so you can go get the data.
Ja. Was ist denn das jetzt für ein Blödsinn? Aus.
You okay over there?
Oh, my Skype was ringing.
Michael, we have serial P2 running to 2.9 megabit reliably with no data loss for eight P2 wire pairs simultaneously.
Yeah, I tried all of that. No, I'm thinking about kind of a stupid idea. I'm following since Bo Schwabe, I think was it. He did some simple thing called ring buffer in the P2, in the P1, and that basically worked by sending a package of n bytes, like 1,000 bytes, whatever, from one P2 to the next, one P1 to the next, and it was kind of a shared hub space around, sent around from one P1 to the next, to the next, to the next, to the next, and back to the first. And anybody could kind of share that running bus, or running package, basically. Like pushing a ball forward, and each P1 who has that package can modify whatever it wants, and then it sends to the next. But they kind of cooperate, share the content. That basically allows to, let's say, have your Ethernet driver running on one P2 or P1, and everybody can access it like a mailbox in a normal communication we have in spin 1 with assembler. You have a mailbox and you put in a request and you get a response out, basically. But if that mailbox is in that shared area, another cog from another P1 can also manipulate that, maybe screen buffer, whatever is in there. It's a
Are these links point to point, or they're all on the shared same lines?
They basically throw a ball to each other. They are standing in around, and they're throwing one package around. Each P1 has that package for a certain amount of time where it can kind of manipulate it, and then it throws that ball to the next one.
So it must be a ring, right?
It is a ring, right?
Yeah.
And it's kind of a project which Bo did years ago on the P1, and it was kind of funny to use. And it depended basically on quite high-speed data transfer. Yeah, I mean, doing it with serial, I already have it kind of running, but I'm thinking of kind of, I don't know. I was looking for a smart pin mode where I can receive data external clocked on n pins.
Well, there's a synchronous serial mode you could use too, but really the serial is just so simple. It just takes one wire, and you can have some kind of baud rate agreement among, you know, your propeller chips, but it would take a cog in each one to kind of facilitate the whole operation. Right. So
and that's basically the plan on the P2 side for me, because I want basically to send around the LUT buffer.
Yeah.
just standing around a lot in a circle, and each participant on the other 7 cogs could kind of request a log, change that buffer, release a log, and then it gets sent. So you can transfer around. And that combined with that feature you have that you use the serial ports to program a ring or a kind of multiple P2s with the same serial lines. I think that could be a nice combination somehow. I'm not really ready with my thought processes there, but what I'm basically looking for is kind of an external clocked input.
Yeah, if you kept it, you know, the speed at which you can go is going to be a function of how close the P2 chips are. If they were all on the same circuit board, it could be pretty quick. If they're on separate circuit boards, like a bunch of edges that are, you know, hooked in an array, then it's going to be a little bit slower. But I mean, look at the speeds that get achieved for those RAM chips. I mean, that's about like a transfer every clock, right? And that's 16 bits per clock. So you could, depending on how many lines you throw at it and how close the chips are, you could get differing speeds. What we need, well, if we could ever make another P2 chip, like a P3, it would be good to develop some SerDes that use LVDS, and then we could really make data fly quick.
So I wonder if
Hey, Brian.
I wanted to jump in and explain myself a little bit. And specifically, I just wanted to say real quick to Terry, man, excellent work. I was planning to build the exact same accessory myself, and it's been on the back burner, and now I don't need to, but I definitely want one of the ones you're going to build. And what I was trying to say in chat is that I have this need to untether my P2 development boards and my P2 product ultimately from being connected via USB like to my development box, right? And I've looked at the ESP parts that was used with the P1 and can work with the P2, and I really don't like a Wi-Fi solution for this because that little bit of lag on connection initiation just breaks the whole flow for me. So I was looking into the WizNet, and fantastic, and I really want to look at what you've done and see if we can maybe work on some spin modules together to get that side complete. And I already have the workings of basically a Rust server that's cross-platform that would be a distributed file system for people that don't really need SD card functionality and would maybe just connect this WizNet accessory and have all the file access their P2 needs from a TCP/IP connection instead of SD card. It's exactly what I've needed. So really cool, and really glad I came to this meeting. And then Chip, on your PMUT question, I've actually put some thought into this, and I heard what Ada mentioned about box 86, and really my thought is actually to port everything in PMUT other than the assembly language compiler to legitimate AArch 64-bit native Raspberry Pi will run well on specifically the Pi 4 or Pi 400 application that does all the debugging stuff. And separately, I've already split the thing in two. It used to be there was only PMUT, but now there's PMUT, and there's also this thing called P2C, which is a P2C compiler that also runs on Linux that just does compilation. And I created that so I can do some automated testing when you do version 37, version 38, version 39, version 40. So it's already separated into two things. And basically my idea is to have P2C run in QEMU user emulation, which should work pretty well on a Pi 4 level device, and then have PMUT proper be the client that gives you the fast workflow, the Visual Studio integration, the debugging windows, and all that fun stuff as an actual, full-fledged native portable Raspberry Pi compatible application. So this is, Yeah, I've done a little bit of work, but not much, but that's where I'm
Okay, so
wanting to get.
the assembly language code is the whole hitch up in the get along, right?
Yeah, I would love to have like a PASM version with an emulator that can run it on PCs or an
Right.
X64 or AR64 or anything else. Yeah.
I've been thinking about this for a while and was starting to get into this whole thing, but then I got back on the file system, so I got to get that done. So about the ESP8266, and you probably looked at the ESP32, there's some turnaround time there, right? But isn't the 32 a lot faster than the 8266?
Well, probably, but I'm just talking about like Wi-Fi lag on connection initiation, even if I'm using like a AMD Threadripper connected to another AMD Threadripper, right? And
So
that it's very slight, but it's jarring to me. So everything I do in my office, I do over wired Ethernet, like 1 gigabit or 10 gigabit wired Ethernet. Yeah, I'm you know, what can I say? I'm who I am.
Yeah, no, I
I don't
understand.
want Wi-Fi.
Okay. Yeah, but I've been thinking a lot about when we talked about this over a year ago of having maybe a compiler written in TypeScript or JavaScript, which uploads to the browser that does all the work. And then the 8266, aside from serving that, can then have face the other direction and have the conversation with the P2 and load it up and do debugging and stuff. And I think there's like sufficiently high data rate. The trouble is there's like group delay, right? As you turn the conversations around.
I think I missed your main question there because I was hung up on I would never use a program editor that runs in a web browser.
Okay, I understand that sentiment as well.
Okay, but what were you getting at? Because I didn't quite.
Well, your concern about the lag time for 802.11, is it just the initial connection time that's causing?
Yeah, I mean, if you do a ping, for instance, you'll see like the first reply takes a lot longer, then it's quick after that. Almost, well, if you have really high level Wi-Fi, the good modern stuff, that's almost as fast as gigabit Ethernet, but not quite. But that lag, I mean, when you're making connections all the time and you get that little 50, 200, sometimes 500 millisecond lag, depending on how noisy your Wi-Fi Bluetooth environment is around. It's just
that initial that initial lag blows it up for you.
Yeah, I've got wired Ethernet all over my office. I use Wi-Fi everywhere else in the house. It's only when I care about fast response because I'm in the flow and trying not to.
Yeah. Hey, now let me ask you a question. So I too don't like. I mean, I have not liked the idea of running things in web browsers because it's just oftentimes clunky and laggy and weird. But do you think it could be done well? Do you think there's any kind of like impediment to actually making it work well that can't be gotten around?
I mean, it depends on what you're the audience, I think. I mean, if you're talking about middle schoolers and high schoolers and maybe even college students, maybe. But if you're talking about professional developers, they know what tools they want to use, especially for editing, especially for interacting with their OS. They know what shell they want to use if they're on Linux. They know they want to use PowerShell. They're experts at PowerShell. They have their favorite editor. They're not going to change. Some people still use VI and they're never going to change. And because they're so productive, why would they change? It would actually be foolish for them to change because they're so good at VI and a terminal window. Some people,
understand.
That's not me, but some people. So it depends on the level. If you're talking about instructional, educational, it's easy deployment. It has all the benefits that web apps have. So yeah, middle school, high school, yeah, probably that's exactly what they want. But me, no, I would never use it.
Okay. For us, we fight a lot, like especially with education, about there's all these IT concerns when you want to hook something up. And if those can be circumvented in some way, and the wire can be circumvented as well, then it's like conceptually ideal because you get around a lot of hangups. So that's our thing, because we have to always rewrite code that's written for Chromebooks and whatnot because they change the way the serial works. And it's just this ongoing nightmare. But so I was
Well,
just kind
I
of,
mean, the other model that education usually likes is a network model where all the students have their own client, but there's a shared server with a shared screen and they kind of timeshare access to it and collaborate with it and stuff like that. And
Right.
that could be done with the Raspberry Pi 4 and a P2 Edge module too, one for the class, but that doesn't quite serve your business purposes as well, I would say. To put
yeah.
it bluntly.
Well, yeah, we just want to make it easy and kind of foolproof. But I'm
Right,
kind
but
of thinking,
I was getting that basically, a single P2 edge card with the right software for sharing it could probably support 10 students,
yeah,
but kind of better from a business standpoint and maybe for other reasons too, to have 10 P2 edges.
well, yeah, usually the students want to have, I mean, it's important to give them their own little piece of hardware so they can
Right.
at their own desk see something happen.
Right. So what I was aiming at actually with what I described before is a Pi 400, or if they want to bring their own keyboard and display and mouse, they could use a regular Pi 4, USB connected to a prop plug, to an edge connector and a P2 PC, and it just works like PMUT, like I showed on x64 Linux.
Right.
Basically. Yeah, that's what I was aiming at. So.
Okay. Do you think, no, I know about web interfaces, they're always like a little janky and they're never the same thing twice on different machines. But what if someone took the approach of actually like completely controlling the screen canvas, right? So they know that pixel for pixel, everything's under control. So there's
That's
not
actually a really bad idea because it would be somewhat slow if you use WebGL to draw it, probably not, but then it would just like crash randomly when the driver happens to have a normal one. Real problem is that it's very bad form to sort of bypass the browser rendering because it's just generally a bad idea. Though there's a lot of layouting. For example, if you open the development tools on anything using the Monaco editor like VS Code uses and like the compiler explorer that you may know or may not know uses, that's if you open up, they actually don't use the normal layouting for the editor. They just have each line as an element and they're positioning it at some absolute X, Y, because the actual DOM layout is obnoxiously slow to react to anything.
Yeah, if you were going to go that route, Chip, I'd actually go towards like a remote desktop client type of solution and do client server that way with no.
Oh, okay.
Just
I mean, there was some movement to maybe try to get the FlexPin compiler to work in a more sort of portable manner where you can link it as a library, but that sort of broke everything, so I removed it again.
Yeah, now of course FlexPrint does work on a Raspberry Pi, so I mean that's an option now too.
Yeah, FlexProp is excellent. I just wish it fully supported the absolute latest version of Spin2 and PASM2.
It surely
the
does.
nice thing about PMUT. PMUT is the canonical. Here's what PASM2 and Spin2 are.
If anything, it supports more Spin2 because it has like. But I don't think it has some of the latest functions, but it does have a bunch. It had the add string first. That's what we say, and it has can load the C library.
I guess what I'm trying to say is pnuts, not pmut, but pnuts, and specifically the compiler part of it is the specification of PASM2 and Spin2 as it exists. It's the best specification we have, and therefore there's something attractive about making that the compiler I use. And for other people that want to be, well, if you like Spin2 and PASM2, then it's great, but you are missing out on everything FlexProp can compile, specifically the C code. Like, it's really helpful to be able to take some good, solid working C code like little fs or UFS or UFAT is one I looked at, and and just be able to just compile it and just include it as a module from Spin. That's brilliant.
Yes,
That's awesome.
basically what it does with the OD file systems, and I
I'll
pretty
live-
much
I'll live
only
on
use the
that.
FlexProp file system these days because it works and doesn't cause headache.
Right. I only want to do that when I've fallen in love with some C code and just don't want to rewrite it. I just want to reuse it.
No, I hate to interrupt this really productive discussion, but I know we have people here that are waiting to hear about the file system progress from
Yeah.
Chip.
Well, there's really not, okay.
All right.
I
So
can
maybe
talk
you
this-
can talk about it just so those who are waiting can go home, and then we
So-
can come back to the
Okay,
rest of this.
so the short of it is I've been off, looking at JavaScript or TypeScript, maybe better, but trying to get a handle on how that whole world works, because I don't know much about it. A lot of you guys do, with the interest of, using it as a tools base. So I just got back onto the file system the other day, so I'm still spooling up like where I left off, because the way this thing works, there's a lot of like little intentions that have to do with, surviving power downs, and a lot of make before break semaphore type things that have to go on with the bits in the flash memory. So, and it's like this thing that all fits together, but it's taken me a while to get back into my head, because it's not just little pieces, it's like one big blob of stuff. So I've just been kind of going through the code and refamiliarizing myself with it. There's not a lot of it, but it's like a tightly bound set of concepts. But I can show you something that I did last night. So I'm hoping in the next week or two to have a release of this, and it'll be simple. I don't think I'll have a command line interface for it, but it'll be able to open, files for reading and writing, and you can, kind of like what Eric's system was doing today, but without maybe so many commands. But once I get this basic stuff really ironed out, adding all that higher level stuff is pretty simple, because the foolproofness is in the deeper parts. So what I did recently, how we added the field access for variables that can be anything and they can be any bit range. So in something like this file system, I have a lot of buffers which are just bits, like single bit flags that contain modal stuff about the state of a sector. And so I've been converting it to use field to access these bit arrays. And there's even like a 12-bit, like an array of 12-bit values, because there's 4,096 sectors. So sectors in this 16 megabyte chip range from like 0 to FFF. So I'll just show you some stuff here about this. So it's kind of my first actual use of the field thing. I made the field thing so that I could do stuff like this, but now I'm actually trying to use it, and I think it's okay. But one of the problems is naming, right, and cache invalidation. So coming up with names to make it look right in the code without getting too verbose, bit of a challenge for me. So let's see here. Where do I go for sharing? Share screen. All right. Okay, so here's some stuff. I assume that's visible. Is it big enough? Should I make it a little smaller? Is that legible?
Yes.
It is.
Okay, so
Very
here,
well, yeah.
this here is an array of 12-bit values, right? And because field can actually, like, if you have a word or a long, you can actually step over bytes, and it'll kind of like put the right number of bits together, concatenating bytes as needed, kind of just overflowing from one byte to another. So we have here some 12-bit variables, which are this, but this isn't a word, which is a 16-bit thing. So really I'm asking for blocks as the number of blocks, which can be up to 4,096. And I want 3/4 of those in terms of words. Does that make sense? I got to have 12-bit elements. So this is a table of 12-bit, like an array of 12-bit values. And then I always add 1 to these things, because you know, if you might have like some strange number of blocks, which are not a multiple of 8. So you need one more full data element block or byte or word in order to house any overflow bits. So here I have like, here's a 12-bit thing. And then here is its associated, that's going to be my field variable, right?
Well, in such a case, it wouldn't it be better to add 15 before you divide?
Say that again.
If
Oh,
you add 15 before you divide, then it will give you a better rounding that doesn't.
Yeah. You mean like, let's see, how would I do this? Times, where would I put the 15 in? Because this is a
you
long
put
word, right?
15 after the 12, the plus 15 after the 12, and then you have to put that all in a the bracket.
Yeah. It would be like this. Okay. I think this is what we need, right?
Yeah, that should give you a more, that should never allocate any extra if it exactly matches.
Beautiful. Yeah, I was thinking about how that would look to type, and it's just a compile time thing anyway, but it takes a lot of brain time to work out. Yeah, so that would handle any fractional. It would kick it over to a whole nother word, right?
Mhm.
Yeah.
Okay, and then this one would look like, let's see, how would this one work?
+7.
Blocks times 1 plus 7. Well, yeah, just blocks plus 7, right?
Mhm.
Times 8. And get rid of this. Okay. Yeah. Thanks for thinking of that. Yeah. Okay. So there we go. So now we'll have sufficient data where we need it. So anyway, these are like the field things. So I set these things up down here. So here's the one where I initialize the ID to block pointer. And this is the little syntax for getting a field pointer. Here's what we want to point to. And then this business here says like the first 12 bits of it, right? Now, and then I do that and here I just want, these are bit arrays, right? So I just want simply the first bit of the array to be in the field pointer. So these are all field pointers. So then when I go to use these things, syntax is pretty simple. We just use field, and then we use that pointer value, and then an index, which in the case of the ID to blocks is going to be a 12-bit incrementer, or in the case of these bit arrays, it's just going to be a 1-bit incrementer. So I've been just converting everything over to use this because it saves memory on these arrays. I had bytes at first, but we really only need bits. And the cost of this, if I like take this thing here, right? This is going to clear a bit. That's what this is going to do. It's going to, the block valid flag index high, it's going to clear that bit. So if I do let's see here, let me drag this down. This is 1928 bytes, right? Let me go back to the source code. Whoops. Okay, where was that? Was this, I think this was it here. So if we comment this out, right, we're just going to get rid of this index to bit clear. Now we're at 1920. See that? So it took like 8 bytes to do that. And I thought it through, and I think it's probably fairly efficient. It's just like 2 PASM instructions, but it pulls in, here's a local variable. Here is a var that's, you know, scoped to the whole object, does this field thing, and then it does a clear. So that all took 8 bytes, which I don't think is too bad. So that's kind of what I've been working on, just getting this thing memory efficient. And then I've got to like respool it into my head so that I can finish it off. But it's working in that, whoops. It's doing the you know, where leveling still. So I'm just modeling only right now about 64 4K blocks, which is 256K, which I can do in the RAM. And so in the end, I'll write the routines to actually erase and program 4K blocks in the flash. And this is showing the red are unused and the green are used. And then this is for the 64 blocks I'm simulating. This is the wear level. So we're just using randomness to pick any block. And then if it's already used, we move it to an unused block. And then we put the block that we were going to write into the old space. And that system works out to get rid of any hotspots in your wear leveling, so that you're not gonna, there's a little bit of variance here between, this is a usage over time. You can see it's going up slowly. So the wear level is pretty even. In theory, it could be about half this, but that would take a much more complex algorithm. But this is like dirt simple. Just randomly pick any of the available blocks. If someone's already there, kick them out to an unused block and put your new stuff there. Or if you happen to pick an unused block, just write the data there. But this effectuates wear leveling without any kind of record keeping. So that's where this thing's at. Any questions? Yeah.
Yes. Chip, it's John Huffman. I just wanted to tell you that I'm so excited that this is finally happening and I won't have to put EEPROMs on my product anymore. And
oh, good.
This is amazing. Can't wait.
Okay, good. Well, I like hearing stuff like that, because it's sometimes these projects, these sub projects can get dry, and it's like, guys, harder to get through. But if you know someone's looking for it, I know John McPhalen wants it. It's an incentive to, power through it. In this case, there was like a lot of thought that went into how to do something like this, so that, if power were to fail at any juncture, you can recover the file system. So like when we rewrite a file, we write a whole nother file, and then we do at the last minute, like a 1-bit changeover, which makes the new write superior to the old write. And then we go and we cancel all those sectors and get them out of the used list. So all that stuff's been worked out. But now the implementation part, that was the fun part. Now the implementation part's kind of a little bit more boring.
Well, if you need me to call you every morning with a pep talk, I'll be happy to be the guy.
I've had guys like that before. When I was finishing the basic stamp 2, some guy in the Navy something proving, I don't know how this guy was assigned, but that guy was calling me every day for an update on when the basic stamp 2 would be done. And it was unreal. It's like I was in the military and this guy was my commander, and he was always on me.
Certain military guys tend to operate that way.
Can we say that again?
Certain military guys tend to operate that way.
Yeah, yeah.
Yeah, I'm former military. I thoroughly understand.
Yeah.
Yeah, they needed it for some kind of project they were working on, and I guess their engineer, I guess he didn't have any other idea how he could do it. He just needed the basic stamp 2. So that guy was always on me wanting reports, and he missed nothing. He was very thorough.
Blow something up. None of your top secret.
Chip, did that help?
Did it help me?
Did it help him get the stamp faster?
I don't really know. I mean, it was a lot of pressure, and I knew I had to get it done anyway, but I don't know. I'm just kind of glad it's over. That wasn't very pleasant. Seemed to go on for a long time at the time. It was like my life, that guy calling me up.
Will this make way to make a SD card driver that works with Spin 2 when you're done with this?
Well, that's what, John McPhalen really wants that. It could. I mean, that's a whole nother thing that I don't really know a lot about. I understand how the flash chip works, at kind of a bottom level. So I know how to do stuff that's safe with it. But I don't really know much about the SD thing. I mean, I don't know, like, you know, whose job is it to wear level? Is that your job, or do they do that? Or I don't even know that.
It's all their job. It just you just write the sector, you just read the sector. It happens automatically.
So they kind of virtualize the sectors for you?
Exactly. It's basically just like a hard drive that you can just access. It doesn't do anything. You don't need to do anything special. You can read anything, you can write anything. It just makes it happen.
Without any concerns about where you've been in the past and the thing.
Basically, yes. It just does things.
Okay, well, that should be easy then.
What?
Don't some of them have their own computer that manages that?
Oh, sure.
Yeah, of course, they all have it. They all have an integrated microcontroller that handles the wear leveling and all the other weird features that they can put into it. There's even some where you can put a picture onto the SD card using, you know, your sector, right? And then it will, that picture will get sent over Wi-Fi to like your computer or whatever. That's an actual product that they made that somehow works.
Wouldn't wear leveling be more keen to a feature of mechanical hard drives as opposed to solid state hard drives?
No, the wear leveling is necessary for solid state because that's where the sectors can wear out.
Right.
The way that
on a mechanical hard drive, that'd be an issue.
No, not so much. On a mechanical hard drive, all the sectors are basically the same. What wears out is the spinning bits. Which
they still relocate sectors on the spinning drives these days.
Actually,
but I
that's
don't
true.
think
If there's a bad sector,
I don't think they just they shuffle them around quite as much because it's kind of bad for performance. But when one fails, they do manage to put it somewhere else. Because they do fail when they're really tiny.
Getting back to the flash and the SD, what would be really handy, Chip, would be a kind of a unified SPI driver that manages those 4 pins that the SD and the flash share. I don't know how much we can do, but right now, like I say, I can talk to the flash or I can talk to the SD, and I manually switch between them. It'd be kind of neat if the driver had some.
I think you should just move the pin setup to sort of notice when it changes and then just reset up the pins. That should probably make it work.
Yeah, I
It's
mean, you could remember state of each, right? You could have some state information, so you don't have to go through a full mount and unmount. You just kind of electrically operate one or the other, right?
But again, it'd be kind of nice if we had a low-level spin2 object. Like, for example, with your flash driver, it would be kind of nice if there was a high level, the file system, and then a low level that actually was just reading and writing sectors on the flash. And then anyone could reuse that low level bit.
Yeah. I see. You mean to.
And if that was kind of could cooperate with SDs, that would be really nice.
Yeah. Yeah, I know John really wants that badly. Well, I'll cross that when I get there. First, I got to get this thing done.
I'm just glad you're working on it, Chip.
Thanks. I'm sorry it's taken so long. My brain has been like the last year, kind of like this expanding wavefront where I'm not really getting anything done. There's not much energy at any point along its edge. I'm just pushing a lot of things kind of slowly. And, but, you know, my performance has been poor.
But Chip, we're doing all that against you to get it done.
Yeah.
I've been having poor performance too lately. I don't know. Don't think I've got anything done in like a month or something, like a little bit, but like not much.
I never had problems trying to keyboard games. Yeah, I've never had a problem with the other content. But
Yeah. Oh, I can do that, huh?
Yes, you can too. Thank you.
Thanks, Chip.
He can unmute himself, right?
Yes.
Okay, all right, good.
Cool.
Chip, I'm
Thank you,
looking
Chip.
at it.
I've got to run, Chip, but thank you very
Okay,
much
Eric.
for your presentation.
Well, likewise, Eric. I
Thank
think,
you too, Eric.
yeah, that FlexProp is like its own universe. It's got everything in it.
Well, you've built the framework that we're all building on top of. So thank you for that. And I'll talk to everyone later.
Okay, Eric. Thanks a lot.
Bye.
Aaron was saying something, I think.
I did, but I'm looking at an article from Reddit from 3 years ago, and they're talking about wear testing, and it sounds like a number of SD cards do include. Again, this was from 3 years ago, so I'm sure the number of cards that include automatically wear leveling is even more now. But how would your wear leveling work if a card also already has wear leveling on it? Or maybe you could just tell John to go buy an SD card that has wear leveling.
They all
Yeah.
have wear leveling if they need to. Partially because the SD standard mandates that you write in 512 blocks, and there's no concept of erasing the block first or anything like that. So they have to do it, otherwise any normal FAT operation would immediately destroy the flash, basically, because it's constantly erasing and rewriting everything.
Yeah, it makes sense. They would have to put that into every flash because it would be quite something to burden every SD product with wear leveling. And I mean, that's like a whole thing that you have to slow down and think about and come up with a strategy for. And it's not trivial.
Exactly. The interface is really as simple as I want this block number, give me this block number, or I have this block number to write, just write it and then wait until it's done.
Yeah. Yeah.
I've written this stuff myself. I didn't write the init stuff ever, I think, but it's basically just a bunch of commands that you send that it initializes it. The most problematic thing is that the old cards, you send them a byte address, so the bottom 9 bits have to be 0, and the newer cards, you send them a block address, so those are just shifted out, those 9 bits, so to make space for more bits at the top. That's basically the only thing to concern about. The main concern is actually finding a card that's small enough to have the old type.
Is there a problem with, I mean, all these cards are SPI bus compatible. They have a SPI bus mode, right?
Yeah, it just works. It is the simplest thing, the actual card interface. Then you have to put like a FAT driver on top if you wanted to actually work with like putting files on it. And that's a bit more complicated, but also not really.
Yeah.
Like they invented that in the 80s.
Okay. Hey, about using a browser and like driving a browser window through, say, JavaScript code. If you make a bitmap that is the totality of the visible space in the web page.
That's actually a big if, because or a big when, because it's actually kind of complicated. I've looked into that once. If you want, because if you have a browser window that is on like the screen that's display scaling, how big is or just if you have the zoom activated in the bottom corner, or on most browsers it isn't in the bottom corner, it's on mine.
Oh,
anyways,
right.
if you have the page zoomed in, the amount of CSS pixels in your page actually gets smaller because it's zoomed in. However, the amount of real screen pixels stays the same. It is, of course, happens also on phones. They're always zooming because they have like 4K screens now, and if you actually rendered it at 1:1 with CSS pixels, you would see like tiny letters that you can't read.
Well,
So
yeah,
it's
there's
actually
some-
very complicated to make a canvas that's the size of the browser window and like has one-to-one pixel mapping. It is possible. They added a thing specifically to make it possible, but it's very difficult, especially if you want to have not just the canvas in the browser window, but you want to maybe have like a DOM element to the side of it or something, or have it like embedded into a page. It gets even more complicated.
Yeah.
I think, Otto, you make a great point, because the even though you want to put an image in there, you still want the scalability and zoomability as a user to go in and look at regions of what's being displayed. So you don't want to prevent that.
Yeah, so basically, if you try to do your own rendering in the browser, it's always like an uphill fight. If you use Canvas, you're getting it probably mostly works. And if you're using WebGL, it probably works very well, but again, it randomly crashes your graphics driver, at least in my experience.
So WebGL lets you do this, but it's
WebGL lets you do anything. It's just OpenGL, but like in web browser.
Okay, I see. Okay.
Proper high performance, everything.
All right. So scaling is always an issue, right? This is
if you're using any sort of I mean, it's a problem with images as well, because the scaling isn't actually very good that they do.
Right. The browser's probably always trying to fit it, and it's and then the user selected some zoom ratio, right?
Yeah, or there's different screen DPI. So like, I don't know what else you might have. You might also have a user that has set the fonts to be bigger, because so they can read it better, but nothing else. That's also an option that you can sometimes do.
Okay.
And there's a bunch of stuff like that, but you can just make it render the page differently.
Okay. So it kind of wants to put things where it wants to put them, and then it has good response and sensitivity to stuff that it put on, like rendered fonts and things like this. That's what it wants to do, right? That's what it's good.
Yeah, that's basically what it wants to do. It wants to just draw DOM elements. Anything else is sort of just like an image sort of getting composited into the page.
But this, I mean, every attempt I've seen to do this, where you have like a monospaced font editor window, it never seems really that solid, right? Is that your experience too? It just seems like
no, the Monaco one that's used in the VS Code, because what VS Code is, it's basically a browser window, believe it or not. And the editor that's used in that is really solid, and you can also just like download it and use it for anything else. So like that's a solved problem, having an editor window in the browser.
Okay, it's a solved problem.
Yeah, it's a solved problem. You just use the good one. Just having a normal text box with a monospace font also just like kind of works, but it's not like good for coding or anything.
Well, yeah, usually my experience is there's always these behaviors that are built into those objects that do things that you don't want to do. You in the end, if you can
it tries to like spell check your code or whatever.
Any number of crazy things. But I mean, in the end, like the way I deal with Windows is I just want the canvas, and I want to know where the mouse is and what key's being hit, and if the mouse is pressed.
Yes, you can kind of do that, but it's a bit jank if you do it in the browser. It's sort of bad UX. You can just use the appropriately named canvas and just draw to it with either the 2D drawing API, which just draws like shapes and things, or the WebGL, which instead is just the OpenGL thing.
Right.
And that's what. But then you have to like more or less make a lot of stuff yourself, and which on one hand is useful sometimes, but I don't know, what the fuck, to get like an editor or something working correctly.
Okay. All right. Well, anyway, yeah, thanks for talking to me about that.
I mean, if you want to see what what the Monaco editor looks like without downloading like something, just go to like godbolt.org. That's the compiler explorer website. It shows you what the compiler makes when you put code into it.
Okay, what .org?
godbolt.org.
Wait, GODBO
LT
Wait, like, wait,
.org.
can you spell it from the beginning?
GODBOLT.org. I've also put it in the chat.
Like godbolt.org?
Yes.
Okay. Okay, so, okay, yeah, so I see here a monospaced editor. It looks really good.
Yeah, this is basically that Monaco editor, and it.
Okay, so Monaco, is this some kind of JavaScript program that people can
Yeah,
use?
it's
Monaco, huh?
yeah. Oh, MIT license even. Uiuiui. That's pretty useful.
Yeah, because that looks beautiful. Looks just right.
Yeah, and it has all your favorite features that you can go multiple cursors.
Okay. All right. Okay, let's save this. Okay, anyway, I don't want to tie up everyone's time with this, but I appreciate the input because I don't know what to think about this yet. I don't know how to think about it. So does anyone have any P2 questions they want to discuss or anything that might have to do with why you came here?
I'm still trying to get into that special I can't think of it right now. That programming interface where you bring in the P, I think, what is it? You bring in the, damn it, it's what's his name? Let me go look for his name up here. I'm sorry. Where are you? Where are Stephen Morocco's golden egg of trying to get into the programming to make it easier. I still can't get in because the videos are gone, and your brother promised he'd have me help, but I still can't get into it. Sorry, Stephen.
Well, what's this about?
Oh, I'm sorry. I'm in the middle of a flight instructor renewal course right now and a geology course. And my brain is elsewhere right now. There was that programming interface where you took it's what's that programming interface were tutoring on or something like that.
Is this VS Code?
Yes, there we go.
Okay.
I still can't get that running. I mean, I need the idiot's guide to VS Code, please.
What are you? Yeah.
I can't get it set up.
What operating system are you trying to run on?
What I tried to do, I started from scratch, erased everything, followed the instructions. I went to the quick bite for it, but the videos in the quick bite are non-existent.
The last time I had someone say they were non-existent, it was a browser problem and a firewall proxy problem.
Now I have I just spent $2,400, new computer, new 50-inch screen, and new printer. So everything's faster and working because I had issues with the computer. So, but I couldn't see those videos in the quick bite.
They're all there. I can actually get to them right now. So there's something else going on.
Okay, I will go back in. This is since our last video conference here. I will go back in again in about a week and see if it was my computer. Hopefully not, but I will. I'll try again. If I get stuck, I'll just have to let you know.
Yeah, what you do is, do you have my email or phone number?
I'll just send my email out to
okay, and then I'll contact you directly.
It'll come up to me, everyone.
Yep. And then what'll happen is if you have problems when you get back to it, I'll set up a quick one-on-one Zoom session. I'll just work through it with you, something like that. I have your email and I'll send a quick intro there.
Sure.
Sorry you're having the problems with this. The first time you reported it, I checked everything too. It's all there and working.
I started on IBM 1130s way back in 370 system. I'm not as astute on the PT as those.
Yeah, no big deal. We all have something we're learning.
What I'll do is I'll stop recording this now. Let's see. Record. Stop recording. Okay.